In this video, I'm going to show you how to find the equation of a polynomial if you're given the properties of that polynomial. So in example A, it says we need to find a polynomial of degree 5. So we want to make sure when we finish and find our answer that that makes sense and matches up with the fact that it should be degree 5. Now, it also tells us that we have a double zero at x equals 1. And there is a subtle difference between 0 and x-intercept. A 0 is any value of x that when you plug it into your polynomial, you're going to get out 0 for y. So that includes all x-intercepts. However, there are some zeros that are not real numbers, and when they're not real numbers, they're not x-intercepts. So basically, all x-intercepts are zeros, but not all zeros are x-intercepts. The zeros are only x-intercepts when they are real numbers. And since this 0 at x equals 1 is a real number, this is also considered an x-intercept. Another word that you might hear also for x-intercept would be root. Okay, so when it says it has a double zero at x equals 1, that means it has a multiplicity of 2. It says 0 twice. So we're going to start setting this up. I have my leading coefficient, which we don't know what that is yet, so I'm going to put in A. You can put in whatever letter you want. I like to use A. And then since it has a 0 at 1, the factor should be x minus 1, because I want to be able to plug in 1 for x and get out 0 for y. Because it says it's a double zero, that means we should have two factors of x minus 1, and it should have multiplicity 2. So the exponent of that factor should be 2. Now it also goes on to tell us that we have a triple zero at x equals 3. So that means we have a factor of x minus 3, and since it's a triple zero, it should have multiplicity 3, which means the factor of that exponent should be 3. Now, it also gives us extra information so that we can plug in for x and y to find A. So this problem gives us 2 for x and 15 for y. So that's what we need to plug in to find what A is. So I'm going to plug in 15 for y and 2 for x. When I do that, I get 2 minus 1, which is 1, and 1 squared is 1. And 2 minus 3 is a negative 1, and when I take negative 1 and raise it to the third power, that gives me a negative 1. So this gives me a times 1 times negative 1 is a negative a, or negative 1a, which means a has to be negative 15. So my final answer when I put all of this together is y is equal to negative 15. There's my leading coefficient, and then I write in all my factors. So this is the completed equation for the polynomial with the given properties. And then if you look, since this is exponent 2, this would give me an x squared term. Since this is a 3, this would give me an x to the third term. And when I multiply them together, I would get an x to the fifth term, which tells me this is degree 5. So it works. Okay, in the second example, it says we have a root of multiplicity 2 at x equals 4. So I have x minus 4 as a factor, so I can plug in 4 and get out 0. And it has a multiplicity of 2, so I'm going to put 2 as my exponent for that factor. And then I have two other x-intercepts, both with multiplicity 1. I have x minus 1 as a factor to the first because it's multiplicity 1. And I have x plus 2 to the first because it's multiplicity 1. Remember, we want to make sure we use opposite signs so that when we plug in negative 2, we get out 0. So then the extra information that is given to us is the y-intercept, which is 0, negative 3. So I'm going to plug in negative 3 for y, 0 for x. Whoops. That should be a 1. And then solve for A. So 0 minus 4 is negative 16, and 0 minus 4 is negative 4, and then squared is positive 16. 0 minus 1 is negative 1, and 0 plus 2 is 2. When I multiply that all together, I get a negative 32a. So a is going to be positive 3 over 32 because I'm going to divide both sides by negative 32. So my final answer is going to be y is equal to 3 over 32 times x minus 4 squared times x minus 1 times x plus 2. And if you see, this here would give me an x squared, and when I multiply it by an x and another x, that would give me an x to the 4th, which would be degree 4, so that matches what the properties tell us in that problem.